let's look at this first part. If I rewrote that, if I rewrote it into log form, I have to notice what the base is. So I'm going to have log base 3 of 5 equals the exponent x. So I plug in what I just found for x as the power. And I'm going to use the property that if I have log base 3 of 3 to a power, I can cancel those out. These operations undo each other, leaving me with log base 3 of 5. Because in this next problem I have the same base of 10, I could say those exponents are going to be equal to each other. So common log of 2x will just be 3. We got to ask ourselves, how could we rewrite 32 to have a base 2? Instead of 32, I'm going to have 2 to the 5th. And now I got to remember my exponent rules. What happens whenever I have a power raised to a power? We'll need to distribute the 5. You have to get rid of those parentheses. Now we can drop the exponents, drop the bases and zoom in on those exponents. And it's like a regular problem. Can you solve the rest of that? Subtract 5x on both sides, divide by -5, and we always have to check our answer. I might have to do arithmetic work during this check before I put it in my calculator. So 4 times 5, I have to know that that's 20, and then I'll put 2 to the 20th in my calculator and see if that's the same as 32 to the 4th. So it does check out. 5 is my answer. Let's get down this idea. I've isolated x, and we learned last Friday how to put this in our calculator. We'll check both the exact and the approximate and see what's the difference. Because I have a base 4 raised to a log base 4, those undo each other, and 15 does equal 15. It does check out. If you put in an approximate number, it should be almost 15.